Okay, let's do one more extra example for class 16 in ES110. Here's another one from our good friends at Hibbeler. And we want to determine the force in member EB, like electric boat, right there, EB. Boom, that's our goal, is to find that right in there. So this is, yet again, another trick to try to find to solve one of these problems. So I don't know what happened right there. I'm afraid. Okay. So in this one we already have the reactions, so we don't have to do that one. Great. And so the strategy here is we're going to take the summation of forces about the B, or the summation of moments about B, right? And so we're going to cut the thing in this thing where they showed it as A right here. They're going to cut here, 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 and here, right? So it's like this little path. So we can expose some of the forces, and what we're really going to look to do is to find ED, right? That's actually the strategy. I don't know how you would know to do this off the top of your head, by the way. This is just I think it's just an extra example, right? That's what we call an extra example. So anyway, I'm going to draw this thing as best I can. And, right, so I'm coming downwards here. We are cutting the thing off right here, so, but it's all going to meet at this point, so whatever that was right there, we could have this and then dash, 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 right, towards the thing. And then have that one, it's all going towards here, dash, 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 and then we have a force right here. And by the way, if we were looking, we notice that's 30 degrees, so that's 30 degrees. And then this one we'd call FDE. I like to go ED for some reason. I think because my name's Edward, like Ed. I don't know, but I don't like the name Ed. Don't like it. Just don't. I don't know. Never liked it as a kid. Don't forget to breathe. So, FBE. Yeah, don't die on camera. FBF. This is FAB. This is 4,000 newtons, 1,000 newtons, another 3,000 newtons. So I wrote it the wrong way the first time I did this problem. And then another 1,000 newtons. And so what we did right here is take the sum of the moments about B equal to 0. And I guess I just marched through. I went negative 4,000 because we're going around this point right there. And that's going to be times 4, right? Yep, times 4. And then we have 1,000 right here. And that's going to be clockwise, so counterclockwise. So that's positive, and then we have 3,000, and that's going to be times 2, and that 2 is going to be counterclockwise. And then we have this this guy right here, and only his horizontal component, right? So it's going to be clockwise, so it's negative, and DE. And so it's going to be the cosine of 30 degrees, right? And it's going to be times this distance. And we didn't get that distance right here. So we actually need that distance. I think I find this somewhere else. I think I went up here. And this angle is 30 degrees right here. So this distance right here is going to be 4 times the tangent of 30, which ends up being 2.309 meters. So That's 2.309 equals 0. So we get FDE is equal to negative 3,000 newtons. So it's obviously it was 3,000 newtons in compression. And that was the method of sections, right? There's the MOS, right? The method of sections. Now use the method of joints, the MOJ, and just use it up to point E, right? So point E right here, we have a downwards of 1,000, and we have a slope coming this way, slope coming that way, and we have a guy coming that way. Right there, right? And this one we know right here. This is the one we just found right here. So that's going to be our 3,000 newtons. And he should be upwards, right? Well, what we could say over here for our EF, it's FEF, right? Between here and here, FEF is this one is at E, and that's the FBD. I could actually start FBD at E would be better. FBD at E instead of at E FBD. Kind of rhymes though, so that's good. That's nice. So if we take a look at this right here, balancing in the X direction, that better go that direction. Balance out, right? Sum of the forces in the X direction equals 0. Lo and behold, I mean, just from inspection, you should be able to say that like FEF, and by the way, this is 30 degrees right here, right? Cosine 30 minus 3,000 cosine 30 equals 0. Therefore, FEF is equal to 3,000 newtons. It to compression, because it's pointing at the thing. And then we take down here, this was our whole goal, right? In the beginning was FEB, electric boat. No thanks. And I don't know which way this is going to go, so let me just point it that direction. I don't know. Tension sometimes is a good default. So take the sum of the forces in the Y direction. And I'll say a negative 1,000. And then I'll take a negative FEB. And then these are both going in the upwards direction. And there's two of them, and they're going to be identical. So why write it twice? Just say 2 times the thing. And 3,000, and that's going to be the sine of 30 degrees. And if I do that, what I end up finding is FEB. Let's get that back in there. It's going to be equal to 2,000 newtons. And it came out to be positive, so my guess was correct. So there you go. It's just marching through the thing, picking the thing apart. I don't know if I would have approached it this way. It's just a technique. You could solve it in a bunch of other ways. This is not mandatory to approach it this way. Just an interesting, different example to try to use. But now you can also try it in other ways. You could do the method of joints for individual ones and march through it, or you could try other method of sections for the thing. So it's up to you. That's all she wrote.